Hi guys, welcome back to my mathematics tutorial. And my name is Peter C. Dr. Jr., mathematics instructor at the University of Liberia and your math tutor. So in this video, I am going to look at the proof of the sum of the difference rule. And this is a continuation of the proof of properties or the rules of differentiation. So if you watch previous video, you will see other proof like the constant rule, the constant multiple rule. And in this one now, we want to look at the sum or the difference rule. And to do that, we're going to use the first principle of derivative or the definition of derivative to have that proof. So now we said the sum of the difference rule. If f of x and g of x, that is if two functions, now f of x and g of x are dummy functions, say that to me that they represent just any function, right? And the variable x, f, and g, they are also dummy variables because we can call it p of x, we can call it h of x, we can use any other function name, a of x, and whatsoever the case might be. I just chose f of x and g of x. So we say if f of x and g of x are differentiable functions, it means if they can be differentiated, then the derivative of f of x plus g of x is just equals to f prime of x plus or minus g prime of x. That is, if you have two functions, you can just differentiate this one separately and differentiate this one separately. So it will be a plus between them. It will be a minus. And mind you, it is not just two functions. It will be 2 or 3 functions, 4, 10, and whatsoever the case might be, right? So let's get started. Now, we told you whenever you have this notation that represents derivative, the derivative of, so what is in here, it is representing the function that you are about to differentiate. And it's clearly seen that whenever there is a stroke like this, it means you have differentiated. If it is not, it means it has not been differentiated. So you understand that these two have not been differentiated. So these are the functions. Now, if we can say f of x equals to this function, right? F of x plus or minus g of x. Now let's use plus, for example. Just not to confuse you, right? Because it will mean the same if you just say plus or minus. Now, f of x in this function, so wheresoever we see this f of x, we're going to replace it with f of x plus g of x. The next thing we need to know is our f of x plus h. So we can derive our f of x plus h, thereby replacing this x in here with x plus h. So on the right hand side, we do the same. We replace this x with x plus h, and we replace this x with x plus h. So we go back down to the problem. We say f prime of x is equal to the limit. So wheresoever I see f of x plus h, I'm going to replace it with this function. So I have f of x plus h plus g of x plus h. Minus right here now, minus. This f of x is just equal to f of x plus g of x. But remember I told you, put it in parentheses because of this negative. All divided by h, as h gets closer and closer to 0. So we have f prime of x now to be equal to the limit. Now, look here. Look at this thing. Look right here. Just look here. So you see that f prime of x. Now the function here is f, right? And the function here is f. The function is f. So f prime of x is equal to the limit of f of x plus h minus f of x. So you see f of x plus h. So to pair this f of x plus h with another function, it must be f of x. The h that was added to it, it should not be in the next function. So you see f of x plus h, and then here you see f of x. So we paired this function and this function. G of x plus h and g of x, we pair these two. So firstly, let's multiply this by the negative. You have f of x plus h plus g of x plus h minus f of x minus g of x, all divided by h as h is approaching 0. So now we can take the first and the third terms, f of x plus h minus f of x, the first and the third term, and then we take the second plus g of x plus h minus g of x. So we can say, okay, let's divide this, let's open this h up, the denominator, h and h. You know that in fractions, when the denominators are the same, you take one of them and just add a numerator, so it's just the same, right? I want to separate these two denominators so that we can see it appearing in this form. Now, the next thing we can do is to take the limit of this first expression and take the limit of this second expression. So now we have f prime of x is equal to the limit of f of x plus h minus f of x all over h, as h is now approaching 0, plus we take the limit of this function, g of x plus h minus g of x all over h, as h is approaching 0. So finally now what we get, we have f prime of x is equal. Now, the limit of this whole thing, you see, f prime of x of this entire function right here is just f prime of x, right? This whole function right here is just equal to f prime of x plus this function right here, g of x plus h minus g of x. So if you just replace this f with g, you notice that in this case, instead of saying f prime of x, you will receive g prime of x. So thus, the derivative of this thing now is just equal to the derivative of f of x plus g of x is just equal to f prime of x plus g prime of x. So similarly, if you can just replace this plus everywhere with minus, you replace this plus with minus, you come here in this first area where you have f of x plus h, which is this expression, and this expression was written right here with a plus sign between them. If you replace this one with minus, and then in here is a minus sign as well, you replace this one with minus, then you pair now, right? So we multiply first. This time this is f of x, so this is also replaced with minus. This time this first term is f of x minus f of x, and negative times negative is positive. So we can pair the first and the second and the third. So the first and the third is being paired right here like this. Then we have the second term, which is like negative right here, right? Negative. So if you're dealing with this term and this term, it's like you have negative g of x plus h plus g of x, and you want to factor out a negative. It means negative times this negative is positive, right? So this would be g of x plus h, and then negative times this positive is negative, so it will be negative g of x. So this means that you will have a negative sign here, and then you have the negative sign in here as well, because negative times this will give you negative, which is this one, and then negative times negative will give you positive, which is this expression. So the only change now will be a negative sign right here. There will be a negative sign here, and there will also be a negative sign in our final answer. So in this answer now, we will have a negative sign right there. So you see, they are both similar when it comes to the proof of it. So that's why we just said plus or minus. So you could continuously say plus or minus, plus or minus, plus or minus, all over. Plus or minus, here, plus or minus here, plus or minus here, not here, but right here, plus or minus, right? You can say plus or minus all over. Plus or minus here, plus or minus here, and it will still give you the same thing, plus or minus and plus or minus. So thanks so much for watching. See you next class.